life of those. So this year we sat down and he said, I want to give a talk, but I don't want to give the same talk. So I said, you know what you should do? You should take apart all of your competitors' products and give a talk on that. That'd be awesome. So this is the fruits of that talk. Give him a big round of applause.
Thank you very much. For many of you know me. We run the 23B shop in Fullerton, which, by the way, our after party is going to be starting, I don't know, 7 o'clock or so after Layerone. I encourage everyone to come that can. Any case, everyone's still waking up? How are people feeling this morning? Awesome? All right, how about some shrimp chips? Who wants a black salted turnip? Yeah! Oh, sorry. All right, how about some Hello Kitty crackers? I think those are less dangerous. All right, so I'm going to dive right into this. We got a lot of stuff. How many of you guys, you want Hello Kitty crackers? All right, it's either that or the Do Not Eat Desiccant pack. Here you go. I'll have more giveaways, don't worry. So there's a lot of stuff to cover. I'm going to dive right into this. But first of all, how many of you guys have taken stuff apart? We like taking stuff apart, right? How many of you successfully put something back together again? Okay, about half? All right. That's how we all get started, right?
It's such a good job. Maybe you got parts left over. That's right.
You know, reverse engineering is a pretty broad topic. It's one of these things that is not talked about. I discovered there aren't a lot of places to learn about how to take apart and learn from other designs. But really, every commercial product you get has probably, somebody in there went to Fry's, bought a competitor's product, and did a teardown, whether they'll admit it or not. So let's start off with some basic principles. So what is reverse engineering? It's basically the process of figuring out how something works. I'm going to borrow from Richard Feynman, the rules of the game. You know, he compares physics to like a chess game you're observing by watching the players play. The key thing, and I think this is lost in a lot of talks about hacking, is that if you want to modify the rules of the game or cheat or change them, you really have to understand them first. In fact, you have to understand them sometimes better than the people who made the game. Couple of interesting things. If you looked at an old Heathkit ham radio or a toaster or whatever it is, from the 1960s through the 80s, chances are if you opened it up, there's a schematic on the inside, a television, a radio, whatever, and they even came with service manuals, theory of operation, things like that. Unfortunately, that's all considered IP for the most part by companies these days, and they lock that information away. They really don't want anyone repairing their product, right? They want you to buy another one. They think everything's IP, so it's a little unfortunate. So what can we do? Well, if we have a few basic tools at our disposal, we can first off repair stuff that's designed not to be repairable. No user serviceable parts inside. We'll learn that that's a lie, just like the cake. We can modify our stuff. So we have something that was not intended to be expandable or to be purposed for other than a dumb consumer end use. Maybe we can make it do something else. We can cheaply source parts. People who make consumer electronics buy stuff in the millions and tens of millions. We don't normally have access to that. They also have modules and things that can be plucked out of that device, and things like power supplies or radio transmitter modules or whatever, that someone spent millions of dollars making this widget cost $3. We can pluck it out and reuse it. Kind of cool. And big things that we can learn from millions of man hours of engineering someone put into this dumb low-cost device and realize it's actually fairly smart inside. Maybe we can pick up a few of those things for ourselves. So how do we do this, right? First off, we kind of need to be cognizant about safety. High voltage, really our biggest danger. A couple of just principles to live by. Anything 48 or 50 volts, somewhere around in there on dry skin, anything higher than that can be dangerous. Anytime you have wet, broken, or compromised skin, far more dangerous, and lower voltages can kill you also. It's just basically you have, I don't know, a few hundred kiloohms to megohms of resistance on your skin. That basically drops to almost a dead short if it's compromised. We have the possibility of shock, even electrocution, if it goes across your heart in some way, completes a circuit. Arc burns, that can happen just even at low voltages, high currents. Arc flashes, those probably won't make you go blind, but they're bad. So pretty simple. A lot of this is common sense. We look out for warning labels, little wires that have much thicker insulation than all the other wires. CRT televisions and monitors are notorious for this. You'll see one wire that has like a 1/4 inch thick insulation and a hair thin conductor on the inside. That's a bad sign. You know, they put 2 inches of insulation around. They don't put, 2 inches of insulation around nothing if they can avoid it, right? So shielding, you'll see things like laser cut or die cut plastic over power supply bits, things like that. And you'll see the universal high voltage warning. That's the one on the left, and the one on the right is used more for power plants and junction boxes and stuff, but you see that too. So lots of devices, you have high voltages one way or another. Big one to look out for, anything that plugs into the wall, right? It's gonna have at least 110, if not 220. Switching power supplies can actually boost that to 300 plus volts before they take it down to 12, surprise. Microwave ovens, probably one of the biggest killers. Those are about 1500 volts, somewhere around there. And they have enough current to kill you instantly. It's a really good source of parts. You can do things like cut the 10,000 turns of hair-thin wire out of the secondary and put a few wraps of number 10 wire and turn it into an arc welder. They're a really good source of high voltage parts too, but you've got to be very careful with microwaves because they will kill you. And then CRT and tube devices, that's like neon signs, plasma TVs even are kind of fall in that category, CRT monitors, vacuum tube, transmitter equipment, microwave stuff to look out for. The key things, you want to power off stuff. When you have powered off something, can it still shock you? Yes. Anyone tell me why? Passive. Right, that's good. Someone gets more church chips. Wearing rubber-soled shoes. This is kind of a good one. In order to electrocute you, it's a lot easier if there's a circuit that completes across your heart. That can happen from your hands, which are usually the thing getting you high voltage, to your feet or across your hands. Wearing rubber-soled shoes, not being grounded is actually a really simple way to avoid that. And keeping one hand in your pocket, that's a really old school, like, I don't know, Navy electrician type thing or whatever. But it's a lot harder to complete a circuit across your heart if there's only one pole. So, basic stuff. And insulated tools, right? I think everyone who's taken a lot of stuff apart has, at some point, touched something and discovered it was hot, or changed a light switch in their house and discovered it was the wrong breaker. Well, it's nice when that thing arcs and pops that at least it wasn't electrically connected to you. You might wreck a tool. So, scary clowns. A lot of you that know me know I don't really care for clowns. You might see some of these wake out slides, so if you see a scary clown, be sure to yell. Can I have a better demo? That's good. All right. So some of the tools of the trade. I've actually brought my take apart tools. I'll spread those out here in a minute. Disassembly, take apart. Your standard screwdrivers, Phillips 1 to 3, they get most of your heavy lifting done. Flat blade, usually used for prying and a few little things. Small screwdrivers, security drivers. An important thing to do. I have a set of these security bits. I have basic stuff. I love these little tiny German screwdrivers made by VHA Corporation. If you're going to only buy like a few high-dollar tools, I recommend putting money into small screwdrivers. They're small, they're little, they're insulated, and they have these really nice hardened tips, and the metal goes like almost all the way through, and they never break. You'll wreck more stuff with cheap tools than anything else taken apart. So I have a lot of screwdrivers. The ones on top are the bigger security Torx, hexes, squares, stuff like that. The other ones are little, security bits. You can tell the security bits, people really don't want you to take stuff apart. They're typically the same fasteners you're used to, like hexes and Torxes, but they have a post in the middle. Payphones have, I think it's a 530 seconds security hex, FYI. I'm saying that's a good source of parts for your project. These little screwdrivers, lots of different varieties. Some of the other things, guitar pick, that's one of my favorite. Those are great for spreading cases apart. A saw blade. One of my more regular hacks is taking a wall wart that's a weird voltage, a switching power supply version, little square bricks that come with laptops and routers and everything. And if you saw a corner of the case open with a hacksaw blade, you can usually pry apart the ultrasonic welds, and you can pop it open, get that case spread. Various sockets, drivers, wrenches. A 1/4 inch high quality ratchet, like a little snap-on, is actually worth buying. You can buy whatever dumb bits you want for it, but that is worth its weight in gold oftentimes. And you can chuck it into like a cordless screwdriver. Really nice. Pliers, tweezers. I really like good tweezers when you start getting into playing with surface mount parts. Little German fine tweezers. Only set you back about $6. Totally worth it. Wire strippers. I recommend getting nice gauge-specific wire strippers. I have a couple pairs. These are actually sized for, and one is more for like number 10 through 16 gauge. The others goes down to 30 gauge. And we're modifying stuff. Little tiny 30 gauge Kynar or Teflon wire is one of the best things. Like if you cut a trace off with an X-Acto knife and you want to move it somewhere else or jack into the little module you built or the programmer, these little tiny things are like gold for cutting up wiring that's there or adding your little jumpers. So this is a spread of my stuff. The upper right-hand corner would be soldering stuff. That's where you're going to have I have very, very fine and medium-sized solder, rosin core, or water clean if you don't mind cleaning it. 100% iso alcohol. You can actually buy that at an electronics store. It's really good, and it will remove stuff that, glue residue and flux that regular alcohol from the drugstore will not do. Magnifiers, we'll get talking about that as well. Static wristband is good sometimes. You need to make sure your equipment is totally powered off and discharged because you are creating a low impedance path to ground with that. You got to be careful. But if you're working on high dollar stuff, especially like sensitive microwave equipment and things with like a really sensitive receiver front end, you can blow stuff up, and it's a good idea to have that. So, okay, we've taken stuff apart. We'll look a bit about that. What do we want to use for, how do we figure out what's going on, right? We can't see electrons. So test and measuring equipment. The most basic thing is a multimeter. How many of you have a multimeter? Right, there's no excuse not to have one. You can spend $400 on a flute with everything and a thermocouple attachment. You can also buy one for $5 at Harbor Freight. I like having a couple of those around because guess which one you're going to sacrifice in something that may or may not have 1200 volts on it? Yeah, you're going to loan one to your neighbor, Harbor Freight, right? AC, DC voltage, find out what wire connects to what, continuity. You're trying to track down where traces in the circuit board go, resistance, really good thing to have. There's a little bit of specialty tool, ESR meter. If you fix stuff, anyone ever heard of the capacitor plague? So there are a lot of bad capacitors made in Asia that have infested electronics equipment made from like the early 90s through present. And you also just find undersized, underrated caps. They're used for filtering power and power supply components typically. Well, that's like the #1 source of failure. They're big, they have a gelatinous ooze inside them, so they're not totally solid state. And oftentimes, good ones are expensive, so they undersize them. Like they'll put a 24-volt power supply filter cap, it'll be a 25-volt rating. One tiny power surge and it goes good night. Well, there's a nice little meter, starts at about $50. You can buy, there's one called the Blue Sea, I think, from Amazon. It will let you test those caps in circuit. You can sometimes find them, and we'll talk about how to identify that stuff. But this is a really cool tool if you're into fixing stuff. If all you're doing is just cutting stuff up and repurposing it, you don't need it. But that is worth its weight in gold. We've probably fixed 5 televisions that way. So multimeter in action. You see that number on there? It says 4.99. What do you suppose that signal is on there? Right, that's volts. So that's a 5-volt logic line. In this case, that was the turn-on line for plasma television. I wanted to find out if the logic board was actually doing what it was supposed to when you push the button. So went from 0 to 5, close enough to 5 volts for me to say that line is probably active. Worth it for measuring so many different things. Some other things, a logic analyzer. This is also a specialty tool and takes some training or practice. But a really cool thing, it does not show you anything about waveforms or what the actual signal looks like. What it does let you do, though, is it lets you see zeros and ones. It lets you capture them at a very high rate and then play them back later. And a lot of them have tools for doing things like telling you what actual English ASCII message was sent through a serial port, or what characters went to this chip in an I2C message to control it. So if you can capture those, store them, write them down, you can figure out what's going on, you can craft your own message and hooked up, you can figure out how to jack your Arduino in there and replay that same message to make the thing turn on, whatever it is you want to do. Invaluable. They can go for $10,000 or more for very fancy, mini-channel, high-speed versions. Nullspace Labs has a very simple one called the Analogic. I think it's like 50 bucks. There's one called Saley that's good. It's totally suitable for a wide range of stuff you'll encounter. Microcontrollers and everything from blenders to televisions to small consumer electronics, musical instruments. This is kind of what the output of that looks like. This is a software-based one, hooked up to the USB port. And in this case, I hooked up what's called an RS-485. It's an industrial two-wire serial protocol from an alarm system. And when I type numbers on the keypad, I was trying to figure out what kind of preamble and message and arm and disarm signal it was sending. Well, you can see this is actually showing me what happened on both those lines. One of them goes high and the other one automatically goes low in exactly the same sequence. And when I put the serial filter on, it's showing me characters like A. So I can see what, I think that's spelled arm or something. So it gives you some cool stuff. An oscilloscope, this is something for measuring fast changes, the AC characteristics of stuff. We're all very focused on software and logic and programming, but you realize that digital signals are just analog signals driven to saturation. That's pretty awesome. Everything that happens digitally has an analog component. When you run something through a wire, you're changing its properties, you're adding inductance and so forth. So these can do lots of cool stuff, and you can also use them to see what's happening with things like transmitters and clocks and so forth. We have an old Tektronix. I would recommend buying an old beat-up Tektronix scope, an analog one. This one's actually digital, although it looks old school and analog. And you can see things like sine waves and square waves and ringing, and you can find out sometimes why stuff's misbehaving. And this will measure volts and ohms and things like that, and depending on how you hook it up. You can measure like the peak-to-peak voltage. Like I can see that this is set to 1 volt per division, that's a square. And so this thing is doing plus or minus 2 volts. So that's basically a 4 volt potential across that. Lots of cool stuff I can do with that. Awesome. Okay, soldering. I assume lots of people here are familiar with soldering. Most of the stuff that we buy is put together with solder, right? It's a low temperature alloy that sticks our copper and steel and lead and tin stuff together. If you are going to modify stuff, you're basically in the realm of rework. So your soldering has to be very good, especially if it's something that was put together in a factory under controlled conditions with automated equipment and skilled operators. So I really recommend getting a good temperature controlled soldering iron. You don't have to spend $1,000. 50 bucks will get you like a entry level Hako or the AUI. There's one they sell on Amazon under like 20 different names. It's not bad. A couple $100 will get you a Metcal, which is really nice, used. They're $500 or $600 new, but that soldering iron makes all their soldering irons look like crap until you get to like the $1,000 range. Super awesome. You want to be able to vary the temperature is the key, and you really want something with a good amount of heat if you're ever trying to unsolder, unseat a component that's soldered to like a ground plane, like a big lump of copper or a heat sink. Also, you guys familiar with lead-free solder? No. You ever seen that? Anyone ever tried to solder it? Yes. Sucks, right? It doesn't wet and it takes a really high temperature. So something you can jack the temperature up or put a high temperature tip on that might fry other stuff, really useful to have. Another trick, you can melt some leaded solder in there. That gives you more surface area for that soldering iron to conduct heat in, and it alloys with the bad stuff, and it makes it melt a lot lower and it lets you get rid of it. A hot air station, also really good for taking surface mount parts off, because the problem is you can melt one lead, but you've got 10 leads on that thing. How do you get it off? Well, hot air is a good way to do that, right? You just heat the whole thing up and plug it off with tweezers. So this is my setup, just a simple hot air station. I think that was like 60 bucks on Amazon or eBay. And then a nice Metcal, that's an MX500. Any of them are awesome. Device programmers, how many of you have ever programmed a chip or a ROM or anything? Any of you done that? So in the olden days, things like burglar alarms and cars and stuff had a big socketed chip, and you could pull it off and maybe you could read the contents. So a lot of that stuff is still there, except it tends to be soldered down. Nowadays we have a lot of stuff that has a microcontroller. So a little 8 or 16 or 32-bit computer oftentimes has its program stored on that chip in flash ROM, oftentimes has other stuff on it. Well, depending on what we have, there are only a few major families of these chips Microchip Corporation, Atmel, the AVR series, the PIC is the microchip, and then various of the JTAG enabled chips with ARM cores and things like that on them. They can be readily manipulated with inexpensive tools that the manufacturer puts the software, the drivers, the cable, the adapters, everything in a package and sells it to you for 35 bucks or 100 bucks. Very nice to have a selection of these. Anything that you're going to be hacking, modifying, etc. Somebody has walked that path before, and oftentimes that designer picked that because the manufacturer made the tools simple and easy to get. And if you can get access to that same tool chain, you've saved days, if not months, of labor trying to reverse engineer something. So these things are really simple devices. It's usually this little circuit board, an enclosure, and a USB cable, and then some software you download or it comes on a CD. There are also commercial packages like IAR that combine a bunch of these tools in one place, and they like to charge you hundreds or thousands of dollars. Some of these have student versions, which will work on the smaller chips, or free versions because they want to get you hooked on their chip. Others of these, like the Atmel AVR products, everything, even full C++ and assembler for their 32-bit chips, those are included in one big free download. And there's lots of open source stuff. So really awesome. Can't say enough good things about owning a few of these and playing with them and doing a few simple projects. So inspection, magnification, a little jeweler's loop is really nice to have. You're looking over something, a magnifier like you see at a beautician's office. A stereo microscope is like the gold standard. That's nice. That's really nice to have. And they actually start at, Charlie, 100 bucks. Was that what you're paying for those?
We got them at 70 for the AMScope.
Yeah, AMScope. Those are awesome. They're basically, you're going to look for a long throat, something you can get your hands under. They're used for like inspection or dissection. They're used for taking apart stuff. And usually want some kind of light on top of it. I have a ring of LEDs on mine I really like. I wouldn't buy the $1,000 ring light they sell for it. I just make something. And you can get up close and personal, things like this, right? You've got some little surface mount